Hello class, this is just a quick kind of help if you're working out this worksheet. This is for Algebra 1. We have Unit 6, Part 2, Review 1. So basically what we're doing is we're working on graphing quadratics and finding intercepts and all the ways to do that. So our first quadratic here that we have to graph, our first parabola, is the shape it's going to be. It's prompting us with some questions. Vertex up or down, U or V shape graphing pattern. So that's letting me know that I have vertex form. So remember, our vertex form is always our opposite sign, same sign. So negative 1, 4. I have a minus in front, so my graph opens down. Because it is a parabola, because it's squared, it's a quadratic, it's going to be a U shape. The absolute value were what made the V shape. And my pattern's 1, 3, 5, 7. So I need to go ahead and make a point at negative 1, 4. And go up 1 over 1, up 3 over 1. Next I would do 5, but it's going to be off the paper. And then I want to connect it with a curve. I don't want to make this into a pointy thing. So on number 2, it says factor to find the x-intercepts. So that means that what I'm really doing here is I'm going to be graphing by factoring. So y equals, this is going to be an x plus 5 times x minus 1. Now remember, when I'm finding intercepts, I'm making it equal to 0. And then I'm thinking about solving that. So it would be 0 equals x plus 5. 0 equals x minus 1, that's 0 product property. To solve, I would have to subtract 5 on both sides or add 1 on both sides. And that's how I'm getting opposite sign for these intercepts. So my x-intercepts are going to be negative 5, 0 or 1, 0. And I want to go ahead and plot those. So now I know that my vertex is going to be halfway in between. So that means like along in there. It kind of helps me to look at a line and not a dot, I guess. So that means my x value would be negative 2. So to find the y value, I need to go back to my equation. I prefer to use factored form. I need to substitute negative 2 for my x and then work it out. So this would be, let's see, negative 2 plus 5 is 3. Negative 2 times negative 1 is a negative 3. This means my y equals negative 9. So my vertex is negative 2, negative 9. So let's go ahead and plot that point. I'm pretty sure the scale goes up to 10. Yes, it does. So there's my vertex. From there, I could do my graphing pattern. I know it's going to be a 1, 3, 5, 7, but you can also just connect what you have. It won't always be easy to graph. Factored form's done. Last one here says complete the square. So I really like this first page. We're kind of telling you what method to use to make it easier. You don't have to decide. So x squared minus 4x. To complete the square, 4 divided by 2. Negative 4 divided by 2. I said divided by 2, but I wrote a different number. So negative 4 divided by 2 and then squared. 4 divided by 2 is 2. 2 squared equals 4. So I have to add 4 and then also subtract 4 and then add 5. So remember, it's plus 4 minus 4 because that really makes a 0, and that means each line of math is equivalent. I want to take the first 3 and factor. That's going to be y equals the quantity x minus 2 squared. Negative 4 plus 5 is a plus 1. So I've got my equation in vertex form. My vertex is 2, 1. And my pattern's 1, 3, 5, 7. And I'm going to go ahead and graph again. Remember, you could always slow down this video if it's going too fast. All right, page 2, we're finding x and y intercepts. So to find an x-intercept, we are letting y equal 0. So let's go ahead and put a 0 in for our y. I'm going to go ahead and try solving this. That's my favorite way. So it looks like a negative 8 and a positive 4 multiply to make 32 and add to make negative 4. So negative 8 times 4 multiplies to make negative 32. Negative 8 plus 4 adds to make negative 4. So then 0 product property, either 0 is x minus 8 or 0 is x plus 4. Let's go ahead and solve those. So either our 8 is x or negative 4 is equal to x. And we want to write those as intercepts. Since I started out with y and ordered pairs are always x comma y, we'll have 8 comma 0 and negative 4 comma 0. To find a y-intercept, we're going to let our x equal 0. So y equals 0 squared minus 4 times 0 minus 32. So after I square 0, it's 0. 4 times 0 is 0. I'm left with a negative 32. And so our y-intercept is 0 comma negative 32. Again, ordered pairs are x then y. We put in 0 for x. Negative 32 was our y. Okay, next one we're doing the same thing to find our x-intercepts. And there might be one, there might be none. So we have seen that on some of the assignments. We're going to let y equal 0. So 0 equals 2 times the quantity x plus 3 squared minus 50. Add 50 on both sides. Then we're going to divide by 2. Our strategy is always to isolate our squared quantity and then take a square root. Okay, now that I have a square root equal to 25, and let's remember the 25 is 5 squared, I can square root both sides. So 5 is equal to the absolute value of x plus 3. So then I have 5 equals x plus 3, or negative 5 equals x plus 3. Solve on both. 2 is equal to x, or negative 8 is equal to x. So in intercept form, that's 2, 0, and negative 8, 0. So to find my y-intercept, I'm going to do that over here. Remember, we're always letting our x equal 0. So y equals 2 times the quantity 0 plus 3 squared minus 50. So 0 plus 3 is 3, and 3 squared is 9. So 2 times 9 minus 50. So remember, 3 squared is 3 times 3. This is 18 minus 50, which is a negative 32. So I have 0 comma negative 32. It's funny, that's just what I got in the last one also. All right, so moving down the page, now we're finding the vertex. So finding the vertex, there's different options. We could do complete the square. Or we could do the factor and find the middle x value. That's the other way we could do it. And I feel like factoring and finding the middle x is the most difficult one. I wouldn't do that unless I had to. So the first one, I have an even, 8 is even, and I have a 1 here, and it's not factorable. And honestly, if I have a 1x squared and an 8x, I think completing the square is easier anyway. So I'm going to write y equals x squared plus 8x plus, and then I have to figure out my magic number, 8 divided by 2 squared. 8 divided by 2 is 4, 4 squared is 16, so plus 16 minus 16 plus 11. We'll factor the first 3. So y equals the quantity x plus 4 times 4 is 16, 4 plus 4 is 8, so x plus 4 squared, and then negative 16 plus 5, when we add those together, making negative 5. So now I've got my vertex, because it's in vertex form, opposite sign, same sign, so negative 4, negative 5. On the next one, I have an odd middle term, so I probably don't want to complete the square, but it is factorable. So let's go ahead and factor. This will be y equals x plus 8 times x minus 1. So my x-intercepts are at negative 8, 0, and 1, 0. So to find my vertex, in order to get the x value, I have to find the middle x. So on a graph, I could kind of look at it. Since I don't have a graph, I'm going to go ahead and add them together and divide by 2. Negative 8 plus 1 is negative 7. Divided by 2 is negative 3.5. So now I need to find my y value that goes with the x. So to find y, I'm going to go back and substitute my x in. So negative 3.5 plus x times negative 3.5 minus 1. And it's not, sorry, not plus x, plus 8. So let's see, this is going to be a 4.5 times a negative 4.5. And so for that, I'm definitely using a calculator. And I get 20.25. So this is going to be negative 20.25. So my vertex is negative 3.5, negative 20.25. Last problem on this page is asking us to select all of the quadratic expressions in vertex form. I think the first one we can tell right away is vertex form. My vertex is actually negative 2, negative 3. The next one almost looks like vertex form. I have parentheses, but there's a sneaky X in front. So there's no square right here. I don't have that, and so it's not vertex form. Same thing on the next one. I have parentheses, but there's no square. It's not vertex form. On D, though, I do have parentheses. X is inside. I have nothing outside. That's fine. My vertex would just be negative 4, 0. Definitely vertex form. And the last one, there's no parentheses. So it'd be tempting to say that it's not vertex form, except I do know my vertex because I have nothing in parentheses with x being squared. It's 0, 4. So that one's going to be vertex form as well. Next page is graphing, and we really want to think about what is the best form for graphing. So on number 9, I can see my vertex right away. It's in vertex form. Vertex is negative 3, 5. My graphing pattern is 2 times the 1, 3, 5, 7, which means 2, 6, 10, 14. So let's go ahead and graph. So negative 3, 5, and then up 2 over 1, and then it would be up 6 over 1, but that's going to be like way off the page. So remember, these are my y values. My x part of the pattern is always over 1. We're not changing anything horizontally in the x direction. We're just stretching or compressing basically in the y direction. The next one, I only have a negative x squared and a minus 6x. There's nothing added or subtracted after that. So what I have to recognize here is that really I probably should just do factoring. So let's go ahead and factor. Let's factor out a negative 1. So then I would have, actually let's factor out a negative x. So negative x times x plus 6. So if I have an x squared, that's 2 factors of x. One of them is out here, the other one's inside. Minus 6x divided by negative 6, or divided by negative x, sorry, is 6. So my intercepts are going to be at 0, 0, and negative 6, 0. This minus sign means my parabola is upside down, that my pattern would be like a negative 1, negative 3, negative 5, negative 7. So 0, 0, negative 6, 0, and then halfway between would be negative 3. So my vertex is going to give me x equals negative 3, but I have to find my y. So y equals negative of negative 3 times negative 3 plus 6. So this means 3 times 3, which is 9. So my vertex is going to be at negative 3, 9. And the reason it's at the top of the page is that I've got an upside down parabola, so it makes sense. On the factored form ones, sometimes you can see your 1, 3, 5, 7 pattern, and sometimes you've got weird decimals and you can't. But I could definitely go in and I could add my pattern on this one. X squared plus 4x plus 4. So I have a 1x squared, the 4x is even, and so let's go ahead and complete the square. 4 divided by 2 squared to figure out that magic number. We're always looking at our linear term at the x term. 4 divided by 2 is 2, squared is 4. So I'd want to add 4, but there's a 4 already there. That tells me that this was already a perfect square. So the quantity x plus 2 squared. So that means my vertex is negative 2, 0. So that means this one only really has one solution. There's only one x-intercept. So let's go ahead and start at negative 2, 0. Up 1, up 3, up 5. It's a 1, 3, 5, 7. Remember, always over 1 in our x direction. Next one, x squared plus 5. Well, that's already in vertex form. Our vertex is 0, 5. So let's start it at 0, 5. 1, 3, 5, 7 pattern again. $13 is already in factored form, so I can find my intercepts right away. My x-intercepts are going to be 2, 0, and negative 4, 0. So let's remember that it's not the exact number that's here, because I have to think that in order to find intercepts, I'm solving with zero product property, I'm setting it equal to 0, and when I'm solving those equations, it's changing the sign, right? Because I have to add 2 on both sides, or I have to subtract 4 on both sides. So 2, 0, negative 4, 0. So halfway between would be a negative 1. So for my vertex, I know that x equals negative 1. I want to find my y. So y would equal a negative 1 minus 2 times a negative 1 plus 4. And that's going to be negative 3 times 3. Lots of 9s today, negative 9. So my vertex is negative 1, negative 9. And I can just connect those. I could also do a graphing pattern on this one. Ooh, that side of my parabola is kind of ugly. And the reason I can do a graphing pattern is because I don't have any decimal points on this, right? If I had a weird decimal point, if my vertex was like on that other one that we did on the last page, if it was just like a negative 11.25 or something like that for my y value, I wouldn't be able to do my graphing pattern. So the last one is not factorable. It's not in vertex form, but I have a 1x squared and an even linear term, an even 6x. So I'm going to go ahead and complete the square. So I want to do 6 divided by 2 and then square it, and that makes 9. So I'm going to go ahead and add 9, subtract 9, and then plus 3. Take the first 3, factor, so the quantity x plus 3 squared minus 6. So my vertex is negative 3, negative 6, 1, 3, 5, 7 pattern again. All right, last page. We are analyzing the quadratic. First, we're going to list the vertex. So the vertex is 2, 3, which means my equation for my axis of symmetry. So remember, axis of symmetry is that line that goes down through the middle. It's a vertical line, so it's an x equals. It crosses through the vertex, so it's x equals 2. That is my x value at the vertex. My pattern for the y values, because of that negative 4, is going to be a negative 4 times 1, 3, 5, 7. Which means negative 4, negative 12, negative 20, negative 28. Circle each row. Well, because I'm multiplying by a 4, my graph is going to be not wider. I don't know why I went to circle it. It's going to be narrow. We are vertically stretching all of our y values because we're multiplying them all by 4. So our points are going up higher and our graph's becoming skinnier and narrower. The graph is going to open down because of the minus sign. And because my vertex is at the top, it's going to be the highest point of the graph. On the next one, my vertex, opposite sign, same sign, so negative 5, negative 2. Axis of symmetry is x equals negative 5. You have to write that x equals in there because it says equation. It doesn't say number. Pattern for the y values. This would be a 1/3 times my 1, 3, 5, 7, which means 1/3, 3/3, which is just 1, 5/3, 7/3. So because we're multiplying by a fraction, we're not going up as much each time for our y value. Since we're only multiplying by 1/3, I guess some fractions could technically make it bigger, right? But we're multiplying by 1/3, so our y values are all smaller. We're going up less and less each time than we normally would, and that's going to make our graph wider. It's going to spread it out. So the fractions are going to make it fatter when we have something that's less than 1 that we're multiplying it by, like a 1/3 or a 1/2, something like that. The graph is going to open up, and our vertex is at the bottom, so it's actually the lowest point. So how many solutions do we have? So this one is crossing my x-axis 1 time, so there's 1 solution. This one does not cross my x-axis at all, so there's none. It's 0. This one crosses my x-axis 2 times, so there's 2 solutions. Last problem, we're trying to find an equation for the graph. So I want to think about my vertex, and that's going to be my HK. I want to think about my graphing pattern, which is going to help me find A. And we're going to write an equation. as y equals a times the quantity x minus h squared plus k. So vertex here is at -2, -4. My graphing pattern is 1, 3, and it looks like 5. So it's my normal graphing pattern, so a equals 1. So when I go to write this in my form, I'm going to erase this because I don't have a lot of space here. I don't have to write down the 1 since it's a regular graphing pattern. I can just write y equals, and then go straight to my parentheses, x minus, well, it's already a -2, so this is going to be a +2. And that's because when I go to take my opposite sign of +2, that gives me a vertex of -2. My quantity is squared, and then it would be plus k. And since k is -4, I'm going to write -4. And I know it works because if I work backwards and look at the equation I wrote and find the vertex, my vertex would be -2, opposite sign, -4, same sign. So you can always check to make sure your answer works. So hopefully this helps you out as you're working through the worksheet. Remember, you can always pause something or play something slower, or look at my work that we're going to post for the answer key as well. But please make sure that if you need help, you're asking.